On April 3, 2026, Elon Musk posted 5 words that sent shockwaves through the entire aerospace industry: 4 to 6 weeks. That's all he said. And with those 5 words, the countdown officially began for the single most transformative rocket launch in human history. Because what SpaceX just rolled out to Launchpad 2 in Boca Chica, Texas isn't just an upgraded Starship, it is a fundamentally different machine, taller, heavier, more powerful than anything that has ever left Earth's surface. We're talking about a vehicle that weighs 11 million pounds fully fueled, generates more thrust than any rocket engine suite ever constructed, and can carry more cargo to orbit in a single flight than every other operational rocket on the planet combined. And the launch pad it's sitting on? That's been completely rebuilt from scratch too. Because the last time SpaceX tried to launch from a flat concrete deck, the engines literally blew a crater in the ground and hurled concrete into the Gulf of Mexico. This is Starship version 3. This is Pad 2. And what's happening right now at Starbase has both engineers and competitors genuinely stunned. Let's dive in. The V3 upgrade, why this is not the same rocket. Now, to understand why the entire industry is paying attention, we need to talk about what actually changed between the Starship you've seen fly 11 times and the one sitting on Pad 2 right now. Because this is not a minor revision, this is a generational leap. Let's start with the sheer size. The fully integrated V3 stack stands at 124.4 meters. That's 408 feet tall. The Statue of Liberty, pedestal included, would barely reach the halfway point. The ship stretches 52 meters. The Super Heavy booster has been vertically stretched to 72.3 meters to accommodate bigger fuel tanks and the entirely new Raptor 3 engine suite. The V3's propellant capacity is staggering. The booster alone carries 3,400 metric tons of subcooled liquid methane and liquid oxygen. The ship adds another 1,500 tons on top of that. Gross liftoff mass hits approximately 5,000 metric tons, 11 million pounds. That makes Starship V3 the single heaviest flying object ever constructed by human beings. But raw mass means nothing if you can't convert it into orbital payload. In its baseline, fully reusable configuration, where both the booster and the ship come back and land, Starship V3 can deliver between 100 and 150 metric tons to low Earth orbit. The previous V2 prototypes could manage roughly 35 tons. We're talking about a 4 to 5 times improvement in a single design generation. And if SpaceX runs it expendable, strip off the landing legs, heat shield, and flaps, the numbers jump to 200 to 250 tons to LEO. Optimized profiles could push past 300. The cargo volume inside the fairing is 614 cubic meters. You could fit entire space station modules, full-size satellite constellations, even small habitats inside without any of the folding engineering that every other launch provider has to deal with. The Raptor 3 engine, the heart of the beast. Now, none of this would be possible without the single most critical upgrade in the entire V3 architecture: the engine. The Raptor 3. Each sea-level Raptor 3 generates 280 tons of force. That's 2.75 meganewtons of thrust per engine. Compare that to the original Raptor 1 at 185 tons and the Raptor 2 at 230, a 21 to 50% thrust increase across just 2 engine generations. And these engines operate at a chamber pressure of 330 bar. That is the highest chamber pressure of any operational rocket engine in history. But SpaceX didn't just make it more powerful, they made it lighter and simpler at the same time. Through extensive 3D metal printing and fully welded joints replacing old bolted flanges, the dry mass dropped to 1,525 kilograms. The total installed mass per engine sits at 1,720 kilograms. The Raptor 2 was 2,875 kilograms. They cut the installed weight by 40% while increasing thrust by over 20%. And here's the engineering detail that really stunned the industry. The Raptor 3 uses internally routed cooling channels and advanced regenerative cooling for all exposed components. SpaceX completely eliminated the external engine heat shield. There is no fire suppression system inside the booster's aft section anymore. They don't need one. The engine cools itself. That is an enormous reduction in complexity, parasitic mass, and potential failure points. The thrust-to-weight ratio exceeds 183 to 1, genuinely unprecedented. Think of it like this. The old Raptor was a sports car with a roll cage, fire extinguisher, and 200 pounds of safety equipment bolted on. The Raptor 3 is a Formula One car that's so precisely engineered, it doesn't need any of that. Now, before we get into what might be the most impressive part of this story, the launchpad itself, make sure you hit that subscribe button and the bell notification, because what SpaceX is doing next with this vehicle is going to change everything. Pad 2, the launchpad, they had to reinvent. Here's something most people don't realize. The launch pad is just as important as the rocket sitting on top of it. SpaceX learned that lesson the hard way. April 2023, Flight 1. The original Pad A used a simple flat concrete deck directly beneath the launch mount. No flame trench, no water deluge. When 33 Raptor engines ignited at full thrust, the acoustic and thermal energy obliterated that concrete, excavated a massive crater, and launched chunks into the Gulf of Mexico. The pad was wrecked. The vehicle tumbled out of control within minutes. SpaceX looked at that crater and said, "Never again." Pad 2 features a massive deep flame trench anchored into bedrock using continuous flight auger piles. The walls are stabilized with reinforced sheet piling. The floor was constructed using deep soil mixing techniques to create a waterproof concrete slurry foundation in the unstable coastal salt flats. This is heavy civil engineering, the kind you'd see on a dam or a major bridge. Inside that trench sits an advanced diverter-shaped steel structure. Rather than a flat water-cooled plate, high-pressure water erupts from multiple points across the angled diverter, distributing cooling and acoustic dampening across the entire blast zone. They tested this system on February 16, 2026, and it worked flawlessly. The deluge system includes high-capacity sump pumps inside the trench that actively collect, filter, and recycle the water back into storage tanks. That means SpaceX doesn't need massive water truck deliveries between launches. The pad recycles its own water. That is the operational efficiency that lets you launch once a week instead of once a month. The launch mount itself has 20 hold-down clamps designed to anchor the super heavy booster until all 33 Raptor 3 engines reach stable thrust before release. The Mechazilla tower is fully erected with its chopstick catch arms installed and load tested. On March 16, 2026, Booster 19 completed a 10-engine static fire on Pad 2. That was the first live fire activation of the entire facility, and Pad A is being rebuilt to the Pad 2 standard for dual-pad operations. The flight test record, how they earned this. How did they get to this point? 5 increasingly ambitious flight tests in a single calendar year. 2025 was the year Starship went from an experimental prototype to a proven vehicle. Flight 9, May 2025. Historic for one reason. The first time any organization reflew a super heavy booster. Booster 14 had already flown on Flight 7 in January. They caught it, refurbished it, and sent it back up. The booster nailed hot staging separation, but suffered a rapid, unscheduled disassembly when a methane transfer tube ruptured under excess aerodynamic forces. Ship 35 lost attitude control when a pressurization diffuser failed. Both vehicles were lost, but the data was priceless. Flight 10, August 2025. The redemption arc. Booster 16 flew a near-perfect ascent. SpaceX deliberately shut down one center landing engine to test engine-out capability. The flight computer instantly compensated by relighting an outer ring engine. Ship 37 broke the upper stage failure streak. It deployed 8 dummy Starlink V3 simulators. The first-ever payload deployment from Starship completed an in-space engine relight, survived re-entry, and executed a soft vertical splashdown in the Indian Ocean. Flight 11, October 2025. The grand finale for Block 2. Booster 15 ran a complex multi-engine landing burn, igniting 13 engines for deceleration and transitioning to 5 for precision control. Ship 38 repeated the payload deploy and relight tests, flew a dynamic banking maneuver to simulate a tower catch trajectory, and SpaceX intentionally removed heat shield tiles to stress test the bare steel hull. It still survived to splash down. 5 flights, 5 massive datasets. Every failure mode cataloged, analyzed, and engineered out. That is exactly why they felt confident enough to make the leap to V3. The competition isn't even close. When you stack Starship V3 against every other rocket either flying or in development right now, the comparison is almost embarrassing. Blue Origin's New Glenn delivers 45 tons to LEO, with a 9x4 version pushing over 70 tons. Impressive, but Starship V3 does 150 tons fully reusable, and New Glenn still uses an expendable upper stage, which fundamentally limits per kilogram cost. ULA's Vulcan Centaur, in its heaviest configuration, maxes out at 27.2 tons to LEO, entirely expendable. A fine rocket, but against Starship V3, it's a completely different sport, and the capability that renders these comparisons almost obsolete. Starship V3 can be refueled in orbit. For deep space missions, lunar landings, and Mars transfers, you can depart Earth's gravity well with a full 100+ ton payload and maximum velocity change. No other vehicle on Earth can do that. It makes single-launch, non-refuelable rockets look like they belong to a different era, because they do. Blue Origin's rushed 9x4 announcement and Mars aerobrake plans are a direct response to these specifications. What comes next? The timeline that changes everything. So what happens after Flight 12? First, orbital refueling. SpaceX is targeting a ship-to-ship propellant transfer demonstration in orbit by June 2026. They'll launch a target Starship into stable orbit, then send up a tanker Starship to rendezvous and dock using Dragon Eye navigation sensors. Cryogenic fuel transfer in microgravity. If they pull that off, every deep space mission on the books gets rewritten overnight. Second, Starlink V3 deployment. The next-generation Starlink satellites are too massive for Falcon 9. Each one weighs 2,000 kilograms with extended solar arrays. Only Starship can launch them. Each V3 flight will deploy 54 to 60 satellites at once, adding 60 terabits per second of bandwidth per launch. That's over 20 times what a single Falcon 9 mission adds. Third, the Moon. NASA has restructured Artemis 3, pushing it to September 2028. Artemis 3 won't actually land on the Moon anymore. It'll function like Apollo 9, with astronauts testing docking and habitation with the Starship human landing system in Earth orbit. The actual lunar surface return has been pushed to Artemis 4, requiring 10 to 15 tanker launches to fully fuel the HLS. And then there's Mars. Musk has stated that SpaceX intends to launch approximately 5 uncrewed Starships during the next transfer window in late 2026 or early 2027. They'll test interplanetary transit, atmospheric deceleration, and vertical landing on Mars. If those work, crewed missions could follow as early as 2028 or 2029. A rocket that weighs 11 million pounds, engines that cool themselves from the inside, a launch pad rebuilt from the crater up, reusable capacity that dwarfs every competitor combined, orbital refueling, lunar missions, Mars landings. All of it hinging on what happens in the next 4 to 6 weeks when Flight 12 lifts off from Pad 2. This is the moment the Starship program stops being experimental and starts being operational. We're covering every single flight, every milestone, every catch attempt, and every Mars update as it happens. If you found this breakdown valuable, smash that like button, subscribe, and turn on notifications so you never miss a launch. Drop a comment below and tell me, what are you most excited about? The orbital refueling test, the Starlink V3 deployment, or the Mars window?